everyone and welcome back to Schoolosophy. So in my previous videos I spoke about linear equations and today I'm going to speak about a topic in physics, that is energy, work and power. So I'm going to divide this into two videos. Now today's video will be on energy while my next video will be on work and power. So let's begin. Energy, work, power. These three words everyone uses in their daily lives. But have you ever wondered what is the scientific meaning of these three? Well, energy is the ability to do work. So energy is the ability in an object to do work. Work is force into distance, where F is force and S is distance. That is, when a force acts on an object and moves it a distance. Now power is work done upon time taken. That is the rate at which work is done. Now each and every object has energy. Even an atom has energy. It has chemical energy stored in it. When you move a box from position A to position B, you apply a force which moves it this distance. So work is done. And when two people lift the same box, but one takes 3 seconds to lift the box while other takes only 2 seconds to lift the box, we say that the second person has more power because it does the same work in less time. Now today we are going to speak about energy in detail. So there are 7 main types of energy. The first is potential energy. There are 3 types of potential energy. First is the gravitational potential energy. Now an object has gravitational potential energy due to its position. An object possesses gravitational potential energy when it is raised to a height from the center of the earth. Like this ball is at the height of say approximately 3 meters from the ground or the center of the earth. So this object, that is this ball, possesses gravitational potential energy. The second is strain energy. Now strain energy is possessed by objects which are stretched. Like a spring, when it is stretched, it possesses strain energy. Third is chemical potential energy. Now every battery and every fuel contains the chemical potential energy. Even an atom contains chemical potential energy. Type of energy is kinetic energy. A body possesses kinetic energy when it is in movement. So now if I roll this ball from this position A to position B, while it is moving, it will have kinetic energy. Or when a ball falls from a height, so while it is in movement, that is while it is moving down towards the ground, it will have kinetic energy. So any object which has movement possesses kinetic energy. Third type of energy is sound energy. Sound energy is produced by vibrating objects. So any object that vibrates produces sound. Now this is a sound wave. Fourth is light energy. Now light energy is due to radiation. Sun is a light source, that it emits light. Now the fifth is electrical energy. Now electrical energy is possessed by static electrical charges or charges moving. That is when electrical charges move around the circuit, they possess electrical energy. We have heat energy. Now heat energy is mostly waste energy. Whatever you do, you always lose some energy as heat. But in some cases, heat is useful energy. Like when you light a wood or when you light a campfire, you use the heat of the flames to give the warmth to your body. Heat energy is nothing but the kinetic energy of the atoms or molecules in a substance. So the movement of the atoms or molecules in a substance. Last, we have nuclear energy. Nuclear energy is produced when the energy that is released from the nuclei of an atom. Now the nuclei is the nucleus which has protons and neutrons. There are 2 ways in which you release nuclear energy. First is nuclear fission and next is nuclear fusion. Nuclear fission is when a large nuclei of an atom breaks down to form 2 small nuclei of other atoms. So this is the process used in nuclear power stations to produce energy or electricity. So a large nuclei of an atom breaks down to give energy and two small nuclei of other atoms. Next is nuclear fusion. This happens the other way around, when two small nuclei of atoms combine to form one large nuclei of an atom. So nuclear fusion takes place in Sun, where two small nuclei of hydrogen or isotopes of hydrogen combine to form one large nucleus of an helium atom. Now there are 7 energies which I spoke about, but in detail we are only going to look at kinetic energy and gravitational potential energy. Gravitational potential energy. As I spoke before, gravitational potential energy is possessed in an object due to its distance from the center of the earth, or in easy words, the ground. Like suppose this ball has gravitational potential energy because it is at the height h from the ground. The other example could be the simple pendulum. When this pendulum is raised to a distance and is held there, it has a distance from the ground, and so it possesses gravitational potential energy. Gravitational potential energy is given by mgh, where m is the mass, g is the acceleration due to gravity, and h is the height to which it is raised. G, that is gravitational acceleration due to gravity, is when an object is the pull of the earth. So when an object is pulled towards the earth, it has acceleration due to gravity, which is actually 9.80, but it is written as 10 meters per second square. It is rounded to 10 meters per second square. So now let's solve this sum. Let's say that this ball has the mass of 20 kg and the height to which it is raised is 3 meters. The g, that is the acceleration due to gravity, remains constant in everything, that is 10 meters per second square. So now the gravitational potential energy possessed by this ball at this height will be 20 into 10 into 3. That is nothing but 600. The SI unit of energy, not necessarily gravitational potential energy, but energy is joules. So energy is given in joules. That is, so this ball possesses 600 joules of energy. Let's see what is kinetic energy. As I spoke before, kinetic energy is the energy possessed by an object in motion. The easiest example could be you roll a ball and it moves the distance A to distance B. So this, because it is in movement, it has kinetic energy. Let's take the example that we used before in JPE. There is a ball raised to a height, so it has gravitational potential energy. Then it is made to fall. Because it is falling, it has movement, and so it has kinetic energy. Kinetic energy is given by the formula half mv square, where m is the mass and v is the velocity. So let's solve this example. A man with the mass of 50 kg moves a distance and he travels at the velocity of 20 meter per second. It is very important that the velocity is given in meter per second, because that is the SI unit of velocity and the SI unit of mass is kg. So we are using that. So let's solve this. Half into 50 into 20 square is nothing but half into 50 into 400, which is 25 into 400, or you can take it as 50 into 200, either way you like it. So that becomes 10,000 joules. So this man possesses the kinetic energy of 10,000 joules. One very important thing we need to know is that when kinetic energy is considered, the distance does not matter as it does for the GPE. Like the height matters to calculate the GPE of this object, but here we do not need the distance. The only two things we need is the mass and the velocity at which it moves. Energy conservation and energy efficiency. These two terms are very important when relating to energy. Energy conservation is when you save energy. The simplest example could be that you switch off the lights in a room when you're not using them. And second is energy efficiency. Now energy efficiency is the transfer of energy with minimum or no wastage. The basic example could be a bulb is provided with electrical energy and it gives you light energy. So when 100 joules of electrical energy is converted in a bulb to 100 joules of light energy, we say that the bulb is energy efficient. Let's see how to calculate the energy efficiency of something. So let's take this example. A bulb is provided with 100 joules of electrical energy. EE is electrical energy. It gives 80 joules of light energy and 20 joules of heat energy. So the formula to calculate energy efficiency is useful energy output upon total energy input into 100. Like for this, the useful energy output will be 80 joules. Why do we light a bulb? Is so that we can have light, not because we need the heat to warm ourselves. So the useful energy output is 80 joules and the total energy input, that is totally 100 joules of energy were put into it. So the total energy input is 100 into 100. So this bulb is 80% efficient. So the efficiency of this light bulb is 80%. So that's it for this video. I hope you understood. If you have any doubts, please put it down in the comments. And please put your suggestions in the comments. So bye, and remember, winners see the game, losers see the pain.